Imagine you are traveling to a planet 30 light years away from the Earth with a speed 60% of the speed of light. So, what do you think how long this trip take? Well, we would say, according to the Earth, it would take 50 years. But here is a mind bender because you in the spaceship will age just 40 years. So, does it mean that you reach the planet before the Earth clock says you should? No, because that's why the relativity is really interesting. Okay, because this specific question that we are going to do now is not just about the length contraction, but also about the time dilation, right? So, in this scenario, when you are moving at a very high speed, not just the time is dilated, but also the length is contracted. So, I will prove you with the help of space time diagram, then how does this happen, right? So, so you see that this spaceship is traveling with 0.60 c, that is a 60% of speed of light. So, so dear student, this is the Earth frame of reference. So what you see that this spacecraft or the spaceship is moving with a speed 0.60 towards the planet according to the Earth, right? So if you measure the distance from the Earth, that distance is 30 light years, which is clearly mentioned. Okay, but due to the speed, a very high speed of this spacecraft, the spaceship, this length will be contracted for the spaceship. And how much this length will be contracted according to the spaceship observer, we can find out this thing by finding out first the Lorentz factor, right? So dear students, this distance is, what I'm saying is, the value of x, the value of the distance according to the Earth observer is 30 light years, right? But when we will calculate the distance according to the spaceship, right, the person, it will be different. So let's see what is our first question, that S arrives P after 50 years according to the Earth. So 30 light years is the distance, the position according to the Earth, and the time, how much time taken, 50 years according to the Earth. So I can just quickly show you this event, that when the then when the spaceship reached the planet, okay, that event we can map it on the space-time graph. Like, let me show you. So, well, on the x-axis, you can see it's a 30 light years at this point. Okay, I hope you see that. And on the 50 years is this point. Okay, 50 years. So, if you join these 2 points, I mean, on the CD prime axis, this one. So, dear students, this is exactly the point that I was talking about. That this is an event when the spaceship reached the planet. Okay. Now, what happened at that point? When, as soon as the spaceship reached the planet, it sent a signal, a radio signal, back to the Earth. Okay. So now a radio signal is an electromagnetic wave that travels with the speed of light. Okay. So this is a radio signal. Okay, so let's see the first of all what they're asking in the first question. They say calculate the time at which S arrives at P according to S clock. So what is S clock? S clock means that during, according to the clock of the person on the spaceship, right? So this is the S clock. So well, we know that it is 50 years from the 50 years according to the person on the earth. So what you see that this 50 years is the value of CT, the observer time on the earth, okay? But we need to find out the value of CT prime, okay? Okay. When the spaceship will reach the planet. Now understand this the perspective of the person on a spaceship, okay? Because the person who is moving, the spaceship is moving towards planet, this is according to your narrative, your perspective. You are on the earth, okay? You are looking, the spaceship is going to the planet. But if I am a person who is in a spaceship, right? So according to my own frame of reference, I am at rest, okay? So that's why the time measured by my clock in my spaceship, I will choose it, or I will say it is a rest time, okay? T0 in our data booklet, as you know. So according to my perspective, I am at rest and the planet is moving towards me. Understand? Okay. So The length is 30 light years between the Earth and the planet, but according to the person, right? Well, that's what I'm saying, dear students. This is 30 light years according to the Earth. But according to the perspective of spaceship, right? As frame of reference, this is moving towards, okay? So you do you understand that? So it means that the length is contracted, okay? I mean to say, so this is a length according to the spaceship, all right? And this is a value of x prime, okay? That's what we need to calculate. Okay, now we have to first of all find the gamma factor, because that will decide that how many times the length will contract and how many times the time will be dilated. So it is equals to the square root of 1 minus v square over c square, that you can write the value of the velocity 1 minus 0.60 c square over c square, right? And then when you will open the square root, so that will change. Okay, so it will be 0.60 square, c square and c square will cancel out. And dear students, it gives us 1.25. This gamma value should be more than 1 if the spaceship is moving at a very high speed. So this will decide. So the time will be dilated for Earth 1.25 times. Okay, or you can say, in other words, the time for the spaceship will get slow 1.25 times. Both are the same thing, right? So the time in the clock of the Earth will run fast according to the person in a spaceship. Okay, so if it took 50 years according to what we see in a question, dear students, I hope I'm not confusing you, that the value of ct is 50 years, right? Now what will be the value of ct prime? Okay, exactly that moment when the spaceship reached the planet, right? So we can find out by this equation, t is equals to gamma t0. Okay, so the time will get slow for the spaceship. So remember, the time will be always less than what you measured on the Earth. You measured 50 years. So the time for spaceship will be always less, right? So that's why it will be easy for you to decide that what is a t and what is t0. Okay, it's a tricky point. It confuses students always, right? So this is 1.25, right? So imagine if I would say it is 50 years. So 1.25 times 50 will become obviously more than 50 years, which is not possible, right? Because time should be less than 50 years. So anyways, this t0 is the time measured by the observer in the spaceship. Okay, so the t over gamma is equals to the t0, right? Let's put the values. So it is 50 over 1.25 is equals to the t0, and that is 40 years. So it means that it just passed 40 years for that person who is in the spaceship, right? Now the next question is, dear students, when s arrives p, s sends a signal radio back to the Earth. Draw on a diagram, space-time diagram you have to draw when it is emitted and until it is received on the Earth. So I had already shown you the event when the spaceship reached the planet, okay, according to the Earth. So it is, I have already marked this point, okay. Since the signal is going backward, right? So, and this is a photon of light, okay. It is traveling with the speed of light, right? So you have to draw the word line of light always at an angle 45. So if it is going to the leftward, then we can draw it. So dear students, as you see on the space time diagram, right, I'm going to draw a line that is going to coincide on a ct axis, right? And at what value, this is very important, right? So it means it is 80 years, right? It would be 80 years, okay. So it means that, so if you're wondering that why it is taking 80 years according to the Earth, so you know already that because the spaceship was moving at a speed 60% of speed of light, so it took 50 years, right? Okay, that's the one thing. Okay, now since the now this is a light signal which is traveling with the speed of light, okay, so obviously it will cover that distance 30 light years in 30 years, okay. So 50 plus 30 is total 80 years according to the Earth, right? According to the person in a spaceship, it will be different. Let's see what is that. So students, our question is determined using the space-time diagram or otherwise. Otherwise means you can use the Lorentz transformation equation as well. The time of travel of signal according to S. S is our spaceship, right? Now it took how much time according to the Earth? It took 80 years. Okay. Now I will explain you with the help of two methods. So kindly stick to the video till the last minute. And this is one of the most important question, right? So I hope I will be able to eradicate all the confusion. So here's the method one, right? Okay. So the moment when the light reaches, when the spaceship reaches the planet and it emitted the signal, right? A radio signal. It is traveling with the speed of light to the Earth. Now, whenever the light travels, because for the Earth and for the spaceship observer, the traveling of a light, the time taken by the light, the speed of the light, I mean speed of the light, is simultaneous. This is one of the important postulate of special theory of relativity, that no matter in what frame of reference you are, the speed of light will be same for all the observers. Okay, so it means the moment when the light signal reached the Earth, at the same time, the spaceship person, the person who is in the spaceship, he also observed the same event. Okay, so if I show you this thing on a graph, okay, because these two events are, I mean, reaching the light signal to the Earth is simultaneous. So I have to draw a line parallel to x prime. You see that I have taken a line, I have a line this parallel to x prime. I will put it on this point 80, right? And I will join it simply. Okay, students, why I'm joining it? Because I have explained you in detail that these two events are simultaneous. So here we go. All right, like this. Okay, so let me write it also. So dear students, I have mentioned it clearly here because the simultaneous event. Now, this is 40 years. I hope you understand that this is a 40 years year, right? When the spaceship reached the planet. So 40 years according to the CT prime, according to the S frame of reference, but according to the Earth, it is 50 years. Okay, and you can see that they are on the same line. Okay, so it doesn't mean that the spaceship reached before the Earth clock says it should. Okay, now dear students, this is total how much? Okay, because you can just, I mean, like imagine, okay, you can see that it is 40 plus 40, right? It is, if I mark equally, right? So I would say that this point is, dear students, this point is 80 years, right? On a CT prime, and 20 more years, right? So this point will become 100 years. I hope you understand, right? 40 plus 40 plus 20. 40 plus 40 plus 20, 100 years. So it means that when the light signal reached the Earth, back to the Earth, according to the Earth observer, it took 80 years. But according to the observer in the spaceship, the total time is 100 years. But how much time the signal took, right? So don't you think we should subtract this time, 40 years, right? Because we are just calculating the time of the traveling of signal, right? You have to exclude this time when the spaceship, according to itself, reached the planet. I hope you understand, right? So that's why, dear students, so that's why, my dear students, this is what you see, right? Is 40 plus 20, right? That's 60 years, right? So 60 years, right? So the total entire journey, right, is total 100 years, but this is in, so 60 years is the time taken by signal to reach Earth according to S frame of reference. So dear student, don't skip the video if you think that the previous method was not giving us accurate, precise answers. So I have brought another method, right? So what is that method? Dear students, it's now we will use both the space-time diagram as well as Lorentz transformation at the same time. Okay. So are you ready? So you know that, okay, we have seen it that it took 80 years, right? We know that it took 80 years according to the person on the earth, right? So this is a value of CT. Understand? We want to find the value of CT prime, okay? That is our goal, ultimate goal, right? So why not we apply the CT prime is equals to Lorentz factor into CT minus Vx over C square, right? Understand? Now, I am going to take the point on the CD, okay, because this is a CD axis, right, and this is a x axis. All right. So, at value of CT is equals to 80. You know the value of x is 0, okay, because it is on the y axis of the Earth's frame of reference. Okay. So when we will put the value CT prime, it is 1.25 into it is 80, right? And minus this would be 0, right? Okay, so v over c square into 0. Clear? So let's see how much do we get. So you see that we got 100 years. Okay, hurrah. So our last method is now verified. Okay, this was correct when I was showing you on the axis by deviance, right? 40, 40, and 20. Okay, now this is a total 100 years, right? So but now we have to exclude, right? What is a time for a signal, right? For a signal to reach. So for this, what we will do, 100 minus 40 years, we will exclude them, and here is the answer, 60 years. Okay, so I hope this video was helpful and you enjoyed the video, and you can check the other video solutions of the other past papers and this past paper as well. And kindly subscribe this channel and share this video. And I will really appreciate of your positive feedback as well as the feedback that can construct my performance more and more. Thank you so much.